Hello everyone, welcome back to my channel. So today we'll be talking about another approach to the meeting rooms 2 question. In my previous video, we talked about how to solve this problem using queue, but today we'll be looking at another approach using the chronological ordering. In today's video, we're not only going to talk about how to use chronological ordering to solve this problem, we're also going to talk about a follow-up question to this question, even though this is already a follow-up question to the original meeting rooms question. So without further ado, let's get started. Similar to our previous approach to this question, our main idea is still going to be reusing rooms as much as possible. So how do we tell whether we could reuse a room? Well, so basically, if you see 2 meeting times collapse with each other, that basically means you'll have to add a new meeting room to all the meeting rooms that you're using. And we don't really care about the specific time of each meeting. The only thing that we care about is if the meeting has ended before the new meeting starts. Because if the previous meeting ended before the current meeting starts, that means we could reuse that meeting room, and we don't need to add a new meeting room to all the meeting rooms that we need. So to achieve that, the first thing that we need to do is we need to sort the meeting times. By meeting times, I'm talking about the start and end times. So we're not only looking at each interval, we're going to separate the start time from the end time and then sort these. But not only with those numbers, we also need to know that for each point of time, whether it's the start time of a meeting or it's the end time of a meeting. The reason that we need to specify each point of time is a start time or an end time is because we need to know that if the meeting room is going to be empty. So if we know it's an end time of a meeting, then we know that the meeting room that's being used for that meeting is going to be empty after that point of time. So basically, after we've sorted the point of times, we'll be looping through those times, and whenever we see a start time, we just add a new meeting room. And whenever we see an end time, we'll subtract 1 from the meeting rooms being used. And the question is asking us to find the minimum number of conference rooms required. So if we think about it, if all the meetings are not going to collapse with each other, then by running through all the meeting times chronologically, then the maximum number of meeting rooms being used during this loop is only going to be 1, because we're subtracting 1 from the meeting rooms being used whenever a meeting ends. Similarly, if we have 2 meetings collapse with each other, then at that point of time, the meeting rooms being used is going to be 2, which is the maximum of all times. So basically, to find the minimum number of conference rooms required, we only need to keep track of the maximum number of meeting rooms used during this loop. Now let's take a look at how to code the solution out. So similarly, the first thing that we need to do is to check if the given intervals is valid or if the intervals contains anything. So if it doesn't contain anything, then we don't need any meeting rooms, because no meetings, no meeting rooms. And then the second thing that we need to do is, since we're sorting the list by each point of times, so we need to store them in a way that we can know which time is the start time and which time is the end time. So we'll be creating a sorted times list, and in the list we're going to store each point of time. So we're gonna loop through all the intervals in the intervals list, and we're going to append both the start time and the end time into the sorted times. So we're gonna append tuples. So let's first store our start time, first element, and then we're going to specify it with the letter S. Similarly, for our end time, interval, second element, and then specify it with the letter E. And once we have stored all the sorted times into our sorted times list, we're going to sort this list. We can just call the default sort method. We don't have to put any lambda function into it because it automatically sorts it by the first element and then the second element. And then once everything's sorted in the list, we're going to loop through the list and to modify our meeting rooms variable. So we need to create a meeting rooms variable. We're going to create the max meetings. And this is indicating the maximum number of meetings at the same time, which is the minimum number of conference rooms required. And then we're going to have another variable called current meetings. And current meetings is going to update every time when we see a new time in the sorted times. And we're also updating our max meetings variable every time we see a new meeting time. But since it's max meetings, so we're only updating it whenever the current meetings is greater than our max meetings. So for time in sorted times, if we're going to check whether it's the start time or the end time, if time, the second element, is S, meaning it's start time, then we're going to add 1 to our current meetings. Else, if it's end time, then we're going to subtract 1 from our current meetings. And at the end of each loop, we're going to update our max meetings. So now at the very end, we're going to return max meetings. And max meetings stores the maximum number of meetings happening at the same time and the minimum number of conference rooms required. Alright, so now let's take a look at the runtime and the space complexity of the chronological ordering approach. So similarly, we need to sort all the elements. So for sorting, it's going to be big O of n log n. And then we're looping through all the times in the sorted times, and that's going to be a big O of n. So overall, the runtime is the same as our using the queue approach. So both of them are big O of n log n runtime. So now let's look at the space complexity. Since we're storing our time intervals, or like the point of times, into a separate array, so that's going to be a separate big O of n space complexity. And the overall space complexity for this approach is also going to be big O of n. And now let's think about what are some of the follow-up questions to this question that we could use the same approach to solve. So like I said before, if you're asked to find the maximum numbers of meetings happening at the same time, then you could use the same approach the chronological ordering approach to tackle that. Another follow-up question could be, what is the time frame that most meetings occurred at? So basically, if you know what's the maximum number of meetings happening at the same time, it should be fairly easy to find the exact time frame that contains the most meetings. Feel free to think about how to tackle down that problem, and feel free to leave any comments down below if you found a solution to that. I might make a separate video on that problem, but I do hope to see your answers down below. And that's it for today's video, and I hope to see you in my next one. Bye!